It really does feel like there's this very clear before and after in the tech world right now.
Oh, definitely.
I mean, before GPT-4, we were all pretty happy if a computer can just write a half-decent email.
Right, or summarize a meeting. That was impressive.
But after GPT-4 landed, the goalposts just moved. I mean, they moved overnight. And suddenly, the expectation isn't just text anymore.
No, not at all. Now we expect AI to see things, to understand the visual world just as well as it understands a paragraph. Multimodality is the new baseline.
It is. But there's this huge catch, right? A problem we have to get out of the way up front.
The black box problem, exactly. OpenAI, for all the amazing work they did, kept the architecture of GPT-4 completely secret.
Totally sealed. We see the magic trick, but we have absolutely no idea how it's done. The research community is basically flying blind.
Which normally leaves the open source world in a really tough spot. I mean, how do you compete with a proprietary giant like that?
You'd think you'd need millions of dollars, a server farm the size of a stadium, and months and months of training time just to even get close.
Usually, yes. That's been the playbook for years. But today, we're looking at a research paper that kind of hacks that system.
Okay.
We're doing a deep dive into Mini GPT-4, a project from King Abdullah University of Science and Technology. And what's so cool about this paper isn't just that it works, but how they did it.
Right, because their goal wasn't just another image captioner. They wanted to replicate those really high-level skills we saw in the GPT-4 demos.
The really flashy stuff, like explaining a meme or
writing code from a doodle on a whiteboard. But they wanted to do it with only open-source parts.
And this is the aha moment of the paper, the efficiency. They didn't build a new brain from scratch. They didn't build new eyes. They took two massive pre-existing models and found a really clever way to glue them together.
It's sort of a Frankenstein approach, but like a really elegant one.
That's a great way to put it, an elegant Frankenstein.
So let's get into that architecture, because the parts are really the key to the whole thing. The first thing that jumped out to me was their choice for the brain. They went with Vicuna.
A very solid choice. For anyone who isn't tracking every single LLM release, Vicuna is an open-source model built on Meta's Llama.
And it was fine-tuned on conversations from ShareGPT, right? So it's already, really good at dialogue.
It's incredibly punchy. The benchmarks put it at something like 90% of ChatGPT's quality for text. So you're starting with a brain that's already got a university education in how to talk.
It knows how to reason, it knows nuance, it's polite.
Exactly. But it's a text-only model. It is, for all intents and purposes, blind. It just lives in a world of words and tokens.
So to give it sight, they needed a visual encoder. And they didn't reinvent the wheel here either. They borrowed parts from a model called BLI2.
They did. BLIP2 is interesting.
Yeah, it uses a vision transformer, a VIT,